All right, what do we got here? Is this the right date? It is not. One. Sound like an old man.
But if you listen to like some of the songs, you understand where I'm coming from. And I'm not trying to sound like a super or overly. I'm not even
I gotta say, I don't like the stuff that comes out now. But thing is most of it. But I mean, there's always good songs though. There's no way you can ever say that like everything is bad. It's impossible. All right, allow Sitlali, Rachel, Melanie, Christina, Joel, Merciful, Cheval, Franklin, Lucas, Jaden, Annalise, Zane, Indira, Kamani, Chloe. Right? So I said I was going to derive some formula, I believe. I think that's where we left off. As I recall. I think we finished this. Yeah, it looks like we did. So then I said like I was going to derive these formulas. Okay. All right. So there's a couple of rules we want to just establish first. So then there's some properties of expectation. All right. So for instance, the first property is that if I do the expectation of the sum of two things, we can think of it as the expectation of the first one plus the expectation of the second one. Or like the mean of the combined random variable is equal to the mean of the first one plus the mean of the second one. If X, let's say, has mean X, and Y, let's say, has mean Y. All right. This is saying if you take two random processes together, and then it turns out if you take their average, you can think about it, the average of the first one, the average of the second one separately, if they each have averages. Does that make sense? All right, so let's just see how this would work. So let's just remember what the formula for expectation is first. Expectation means that you're going to take the sum over all the values times their probabilities for everything in the sample space that's possible. Do you remember this formula? You spent a bit of time doing it before. The weights times the values. Does that make sense? All right. So I'm going to try and show this first. Okay. So if we take two random variables, we want to start saying what the probability is that we're going to be able to effectively like add them together, sort of. So this has to be, by definition, the first one plus the second one, then times the probability that you end up getting xi and yi. So you know what? I don't know if I want to write this out. This is probably going to be typed better if I just find a good one real quick. All right. All right, so this is pretty much what I was just saying. So. All right, so the linearity of this thing is going to follow from the following. So like if you say e of x plus y, this is x plus y. He's calling it omega instead of I, where we're saying, but then that's, you could write that as I, it makes no difference. Does that make sense? Does that make sense? So then I is like saying, oh, we're going through all the different things. So the probability that you get that particular value, okay, I'll just write it with the I so you don't get confused. So he's just writing it like this. Because these things are going to happen, like that's like the first case, then the second case, then the third case, etc. It's the probability that you get the first case, the probability you get the second case, etc. So then this is the same thing as saying like x1 plus y1 times the probability of 1 plus x2 plus y2 times the probability of 2 plus then this is going to be whatever the last possible thing that we could have is times the probability of the nth case. Does that make sense? Does that make sense? Now, this could be separated and we could rewrite this and we can start saying it's going to be like, we could put all the x's together and we could put all the y's together. So it could be like x1 plus x2 plus xn. Oops. Sorry. x1 times p of 1 plus x2 times p of 2 plus xn times p of n. And then I can put all the y stuff together. Y1 times p of 1 plus y2 times p of 2 plus yn times p of n. Do you understand what I'm doing here? I'm just keep taking all the x stuff, writing it first, taking all the y stuff, writing it second. Does that make sense? But this is the definition of e of x. And this is the definition of e of y. Does that make sense? Because like the y's times the probabilities, this is the x's times the probabilities. Does that make sense, guys? All right, now the second thing is that they wanted us to say something about is if we start talking about the expectation of some number times a random variable. So C is not random. C is a number. So what does this mean? So it's like, oh, if we took all of the, let's say we start saying how much money does each person have? Each person has a random amount of money, right? And then I'm going to say, oh, let's pretend like we're going to just double it. Double the amount of money this person has, double the amount of money this person has, whatever, double all the money. Does that make sense? And then we want to take the average of that. Well, it turns out it's just going to be double the average of the original thing. So they want us to be able to say this also. So then if we have the expectation of some constant times some random variable, then by definition, this would mean then C times the value times the probability it's going to occur. Does that make sense? Then this would mean C times x1 times the probability of 1 plus C times x2 times the probability of 2 plus whatever the rest of these possibilities are. X, the last one, times the probability of the last one. Does that make sense? But then C can be factored out of all of these things. So then we have x1 p of 1 plus x2 p of 2 plus blah, 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 plus xn times p of n. But then this again is the same thing as this is the same thing as this. So this is really just C times the expected value of the random variable. So in other words, if we asked if we double everything beforehand and then asked what the average would be, it should be double the original average. Does that make sense? Does that make sense? So then they say that these two things combined, we say that expectation is linear. So if we write like expectation of A times X plus B times Y, where A and B are constants, then what you could say is because we can break up the plus, you're allowed to say A times X and B times Y. And then you're allowed to take the constant out of this thing. So then you're allowed to say this is A times this plus B times that. In other words, the mean of some constant times the first random variable plus the constant times the second random variable ends up just being the constant times the mean of the first one plus the constant times the mean of the second. Does that make sense? All right, why are we doing this? So it turns out we can use these rules and it'll make it pretty easy for us to be able to figure out what the mean and the standard deviation are going to be of the binomial distribution and of some other distributions that we have to talk about later. Okay? Questions so far with this? All right, so let's just also recall the formulas, or they want you to know the formulas now for mean and standard deviation of a probability distribution in terms of this type of thing. Okay, so we have to talk about that. So if I start saying mean, we just did that obviously already. This is mean. We talked about that before. All right, oops. All right, so then I want to just remind you the formula now for standard deviation. So we don't really calculate, it's hard to calculate standard deviation first. Standard deviation, as you recall, is equal to, the regular standard deviation formula is S is equal to the square root of the sum of xi minus x bar squared, all divided by n minus 1. And then sigma was equal to the square root of the sum of xi minus the mean squared, all over n minus 1, where this is the population parameter and this is the sample statistic. Does that make sense? So like this is like something that's just like, true all across everything. This is just the mean of the sample. Does that make sense? This was the sample standard deviation, and this is the population. Right? Does that make sense? All right. So then this, if we square both sides, we can write the variance. So these would be the population. Oh, I'm sorry. This shouldn't say n minus 1. It should say n here. I apologize. That's the major difference. All right. Population, you have the entire population, so you can just take the average. You don't need to sit there and divide by n minus 1. Sample, we're saying we don't know as much about the thing, so we start dividing by n minus 1 instead to make it a little larger. All right. There's some more reasoning behind that we can say, but I'm just not getting into it. All right. So then this. Now, this formula here, if we were to write it in the frequency distribution format, we could write something like this, I guess. The frequency of how often the particular value occurs, all divided by the total frequency, n. And then we could do the thing that we did before, where we just sort of bring this inside here, because we're dividing all of them by n. So instead we can start dividing by individual frequency by n. What if we take the individual frequencies and we divide them by n? What would that be the same as? Sorry? Sorry? No. What if we take the individual frequency of some x value and we divide by n? What would that be giving us? We take the frequency and we divide it by n. Sorry? The weight? What do you mean by that? What do you mean by weight? The percentage that it occurs. This is the relative frequency from before. We did this the first day. Does that make sense? All right. And then we did it again when we started talking about probability. And then we did it again last class, I guess. So then this thing here is kind of how often that value would occur. Is that correct? Well, if we did this for all the values in the entire sample space, this is the probability that that value occurs. Does that make sense? So then this is the same thing as the sum from I equals 1 to n of xi minus mu squared times the probability that that particular x value really occurs. Does that make sense? Does that make sense? Do you understand, Chloe? All right. So then the thing is that this, so I'm just writing the other formula down here next to it because this is sort of why you can see, I guess, why we want to use this other notation. instead of writing stuff with this sum stuff, because it starts becoming like too much. So this was the definition for average. Does that make sense? Does that make sense? But then what we say here is this, that, so this is the average of this. This is the average of whatever this is now. So that's the mean minus, or the value minus the mean squared. And that's referred to as the variance of the random variable x. Does that make sense? We talked about that formula a bit the other time, but this is just another way to write it. Does that make sense what I'm saying? All right. Do you understand? Question? All right. Now there's going to be some properties of variance that we have to talk about a little bit also. Okay. But these are going to be easy actually. And one of them is extremely important. All right. So oh my God. All right. So I'm going to use something we just did from before to do this one. Does that make sense? So we don't have to write out as much, hopefully. Okay. So then this is going to be the variance. I'm just going to try and keep the formula here also, this formula. Because that's this other way that we can write the variance. Does that make sense? All this is the weight or the amount of times percentage that this value occurs. And then we're doing that value minus the mean squared. Remember, we did that when we were doing standard deviation. Does that make sense? Standard deviation just means you take the square root of the whole thing. Does that make sense? All right. So then this, so it's like the average square distance. Does that make sense? All right. So the variance of c times the random variable is equal to the sum from whatever. Oh no, I'm sorry. Let's not write sum. Let's write expectation of. Then this is going to mean that this has to be c times x. Oh, another thing. Sometimes people write this here. Sometimes people write it like this. Instead of writing the mean, sometimes they write expectation again. Does that make sense? Expectation means mean. Does that make sense? So those two are the same. Does that make sense? All right, so here, so another way to write or to say how to do this is it's c times x minus the mean of c times x. All right, this looks like it's going to be really hard, but it turns out it's going to be actually very easy. All right, so do you remember when you have like a minus b squared? How you do this? How do I write this out? No. Just a minus b squared. Just with numbers or variables or whatever from algebra. Yeah, but I'm saying if it's a and b, not with numbers. How you do with variables? A minus B times A minus B. I mean, you should not all be looking at me like you can't do this. All right? A minus B times A minus B. Is that correct? Then what? Yeah, how do you multiply them? So yeah, so what do I write? A times A is A squared minus 2AB is correct. Minus A times B minus A times B. Then minus minus becomes plus. You have B squared. Is that correct? So then we could write this, I guess. A squared minus 2AB plus B squared. Is that right? Does that make sense? So we could just do that here, to be honest. There's something here, and there's something here that's just the A and the B. Does that make sense? It's the same stuff. Does that make sense? All right. But I'm not even going to do that. I'm just going to say that this expectation thing, we can take the C out. Does that make sense? So then we get C times X minus C times E of X squared. And now this C is common here. Does that make sense? C can be factored. So then in this case, this is E of this C factors. C is common, so I just brought it out. Does that make sense? Now it's being squared. So I'm just going to square it. Does that make sense? Now this is a constant again. So it again can be taken out of this thing. What does this thing mean again now? That is the variance of X. That's the same thing we actually just wrote right here. Does that make sense? Because this is the average of the value minus the mean squared. Does that make sense? E just means average. So this is C squared times, this is really just the variance of the variable X. Does that make sense? In other words, the variance of some number C times X is equal to C squared times the original variance. Some number. Like if you took everything and multiplied by a number. So in other words, like if something is variance is sort of like how spread out stuff is, right? What this is saying is like if you multiplied all the numbers by a particular number, now the variance is going to be multiplied though by that number squared, the original variance. So however spread out they are. Does that make sense? Oh, this thing just crapped out again. Okay. Okie dokie now. This one. The variance of x plus or minus y is equal to the variance of x plus the variance of y. All right. Let's just do a little example first to see if this makes any sense first, because this is something that people would not usually ever start saying is true without first thinking about some situation first. All right. Let's say I say that you have a certain amount of money. All right. And you have some amount of money. The first person, let's say, has some amount of money that is some number between 0 and 100, but it could be any of those numbers. Does that make sense? Does that make sense? The second person, let's say, also has the same amount of money, 0 to 100. And then again, all of these numbers are sort of just as likely as all the others. All right. But I mean, any number between 0 and 100. Does that make sense? $12.62, whatever. Does that make sense? Yeah. Anywhere between 0 and 100. Okay. Could be 0, could be 100. So then all right. If I started adding, so like this sort of then tells you like how spread out they are. Is that correct? Right? If I started adding the two numbers, so now there's two people that walk in. We start saying how much money would they have between them? What would the range be between? Nope. What's the smallest amount of money they're going to be able to have, and what's the most amount of money? 0 and 200. They both could have 100, so now they can have 200. Is that correct? I will add, right? So then all right, what about if but what we've noticed here though, when we did this though, is it seems like the amount of spread or variation actually got wider. Is that correct? Like this was only like 0 to 100, but this became like more possibilities. Is that correct? Does that make sense? All right, that's kind of expected, I feel like. Is that right? Does that make sense? All right, what about if we did when we subtracted the two things? No. If the first person has somewhere between 0 and 100, second person has between 0 and 100, what would this be between now? Negative 100 is definitely the smallest this could be. What's the biggest it could be? 100 is correct. So this guy could have 100 and this one could have 0. Is that right? This one could have 0 and that one could have 100. Is that correct? But the interesting thing is that this had like a range of 200 and this also has a range of 200. Now it turns out that the range is directly related in this case to the standard deviation, but that's not always the case. But nonetheless, you see with this that it seems like even though we subtracted these two things, the variation actually got larger in like pretty much the exact same way it just did before. Does that make sense? Does that make sense? All right. So that's what, do you guys get what I'm saying here? But that's what this is sort of saying also. It says it doesn't even matter if you add or subtract the random variables. As long as they're independent, we just take the variances and we just add the two variances. Does that make sense? Variance doesn't get smaller when you do more stuff, right? More variation. Is that correct? All right. So then so now we got to show this thing, whatever this is. Okay. So then this is going to be the variation or variance of x plus or minus y is equal to, now I'm going to have to do it like the algebra. So this is this x plus or minus y minus the mean of x plus or minus y squared. This is, now I'm just going to square these two things. Like I'm treating this effectively as my A, and this is my B. Does that make sense? Then this is going to be this part squared. Actually, I'm sorry. I'm going to rewrite this first before I do this. I'm going to write it differently. It'll be easier. So I'm going to write x. Then this says minus here. This part here can be rewritten as x e of x minus e of plus or minus y. We can separate this out. Does that make sense? So then this is x minus e of x. Then there's this plus or minus nonsense. Plus or minus y minus e of y. So I'm grouping this with this and this with this. Does that make sense? I'm just writing them next to each other instead of writing them separated. Now you treat this as A and this as B, okay? Then this is going to equal to this thing squared, whatever that is. Plus or minus. This thing is also going to get squared. Does that make sense? A squared, B squared. Is that correct? Then the middle part was like 2AB. Is that correct? 2 AB. Does that make sense? A squared, B squared, 2AB. Okay? Then this can be separated again. So this can be written as E of this first part. I'm going to write this also over here. And then there's this thing. I'm going to take the 2 out. So we have this. This one's here, that one's there, and I just rewrote this over here. Does everybody see that? Does that make sense? What is this? That's true. What else is this though? Yeah, that's what you just said right here was the variance of x. This is the variance of x. This is the variance of y. People call this part here the covariance of x and y, okay? But I just said before that the formula is going to be the variance of the first variable plus the second variable, I said was going to equal to the variance of the first variable plus the variance of the second variable. What does this have to equal to then? If this is supposed to equal to this plus this, but I'm getting this plus this plus this. What would this have to equal to? If this was equal to this plus this, then we start getting two of them. I didn't say the formula was equal to two of them. Does that make sense? I just said it was the first one plus the second one. So I have the first one plus the second one, but then I have something else here. What does this have to equal to? If I'm correct. If this formula is correct right here, what does that have to be? I'm just saying like this part is the same, right? So that's right there. So all of this is pretty much the same except for that. If this is going to be true, what does that have to be? 0. Does that make sense? Does that make sense? If it's not 0, it's not the same formula. If this was equal to like some other number, right? That can't be the answer anymore. I would have to say what that number would have to be. Does that make sense? So, well, actually, I'm going to explain why it has to be 0 also. But I'm just saying, if this is going to be true, that has to be 0. Does that make sense? Well, no, I'm going to explain why. Okay. But if this is true, that stupid thing has to be 0. Does that make sense? All right. So let's see why this has to be 0. Does that make sense? All right. So we have this thing now, whatever this is. All right. But I said something before. X and Y, I'm assuming, are independent. And we haven't really used that part yet, but we're going to use it now. Does that make sense? Yeah, right. Let's do something else first. Otherwise, this gets even more confusing. So let's say I just have this, just that. Does that make sense? Not all this other crap, okay? Because it turns out this stuff doesn't really make very much difference because if those things have averages, those are just numbers. Does that make sense? Like, I don't know, this is 2. This is 3. That's not as hard to deal with. Does that make sense? All right. This is a little bit more annoying the way it's written. Okay. But if we can do this, we'll be able to do this. Okay. All right. Well, what does this mean by definition? This is what? The sum of the x value times the y value times the probability that that thing is going to happen for all the values in the entire sample space. Does that make sense? Does that make sense? The average is the value times the probability. Is that correct? Now it's just the value of the product of these two things. Does that make sense? Actually, sorry, this needs to be written differently. I gotta write this differently. I'm sorry. This might get confusing. What do I mean by the value? The value is the random variable's value. Frequency is how often that thing happens, right? All right. This is actually a little confusing for this one here. All right. So now this is saying x times y. X times y. Well, now we have to talk about all the different possibilities of x multiplying by y now. Does that make sense? So I have to write this with two summations. Because the x doesn't have to be the same thing the y has to be at the same time. Does that make sense? So I write them with two different indexes. Does that make sense? Now I need to talk about the probability of each one of those things happening. So this is xi and yj. Does that make sense? Like it's going to be like x1, y1 plus x1, y2 plus x1, y3. And then you're going to keep doing it for all the y's. Does that make sense? Then it's going to be x2 times y1 plus x2 times y2 plus whatever, the rest of these. Does that make sense? You got to do it for all of them. So I'm just saying I got to keep changing like both of them. So that's why I'm writing two of these. Does that make sense? All right. Now, this looks like this is going to be completely disgusting, and it kind of is, but this is the part that's going to end up mattering. Okay. All I'm going to do now is separate this because they're independent. We can start saying it's the product of the two probabilities as opposed to just this probability. Does that make sense? So this can be rewritten as that. That was the definition of independence from before. If we have this, we're allowed to start saying it's that. Is that correct? That was how we did like the slots all the time. Does that make sense? All right. Now this looks pretty stupid also. But this thing says J here. This part changes based off the J's. Does that make sense? But this thing doesn't have to do with J. And this thing doesn't have to do with J. Does that make sense? And we use kind of the same idea that we did before over here. The C had nothing to do with the I. Does that make sense? There was just a C everywhere. Is that right? So we can just take the C to the outside. Is that correct? Does that make sense? Because the C is not changing. Is that right? You understand? Well, for this J stuff, this part's not changing and this part's not changing. Does that make sense? So now I'm going to take this over to here and I'm going to take this over to here also. So then we have I, xi, p of xi. Then there's still this sum j thing on the inside here. Yj, p of yj. Does that make sense? What is this though? What is that part? The blue part? What is this thing here? What is this? That's the expectation of x. Is that correct? Or the mean of x. Is that right? What is this then? That's correct. This is the expectation of y or the mean of y then. Is that right? Good. This then is just the mean of y. I'm just going to write it that way. Does that make sense? But now this stupid thing is now a constant also. The mean of y, I don't know what it is, but it's like 5 or something. Does that make sense? It's the mean amount of money that people bring in. I don't know. But whatever it is, it is. Does that make sense? So it's not random. It doesn't change based off of I. Is that correct? So what am I going to do? Take it out. Then we have this times this. What is this then? The mean or expectation of x is correct. This is e of y then times e of x. In other words, we just proved that if you have e of x times y, and this is going to be if these two things are independent from each other, you just take the product of the two individual averages. Does that make sense? Which is what you'd want it to be. Is that correct? If they're independent from each other. If they're not independent from each other, all kinds of stupid things can happen. Okay, but does this make sense? All right, I'm sorry this is taking so long, but there's a couple of things in here, believe it or not, that actually end up being very useful. All right, so and I have to say that these things, when I was in this class, became extremely important for me later. Okay, and no one really ever taught it to me correctly, but the teacher that taught me this class. So that's why I'm going through it. Does that make sense? There's one other thing. All right, so then sometimes we want to talk about the mean of a, or let's say they sometimes refer to something as a centered random variable. So, I don't know, x minus e of x is called a centered random variable. All right. If I do the variable minus the mean, does that make sense? Why are we talking about this? Because z equals x minus mean over standard deviation. Does that make sense? Does that make sense? All right. But there's a neat thing you can do with this now. Once you know some of this stuff. All right. So you write all of these things, and then you hopefully start remembering what the formula is. Does that make sense? But then you want to write it ever again. You just want to use the results. Does that make sense? All right. So I want to say, what is the average of a centered random variable? Now, why am I asking this also? This is centered. This is centered. Does everybody see that? Does that make sense? So what is the average of a centered random variable? Okay, well, then that would mean I would have to do the expectation of this, whatever this stuff is. Does that make sense? You just start writing the E thing. Does that make sense? Okay. Well, this would be the expectation of this minus the expectation of whatever that is. Is that correct? Just separate it out. Does that make sense? We did that way at the beginning. Is that correct? This is not random, though. The average of the x's is the mean of the x's. Is that correct? So this is really just the mean of the x's. Is that right? Yep. Good. Also, by the way. Okay. So this is the mean of the x's. Does that make sense? Minus the mean of the x's. The average of the averages is the same thing as the average. But if I start taking the average of something that's not random, right? This is not random anymore. Does that make sense what I'm saying? So if I'm like the average of 5, okay, it's 5. Does that make sense what I'm saying? All right, so then this, it's a good question though, okay? But like this effectively can be taken out of here. Does that make sense? So then this is going to be like this, so you get 0. Does that make sense? All right, what am I talking about here? Everybody sits here and let's say they have between $0 and $100, right? You randomly bring in $0 to $100. Let's say the average is $50. Okay. that make sense? All right, but before you walk in, I'm gonna take $50 away from you. And if you, I'm gonna take it, I promise. It's like the no, but I'm gonna take $50 away from you. Okay. So if you have 20, you owe me 30. Does that make sense? If you have 100, you still have 50. Does that make sense? And then I say, what's the new average? How much everybody has now, right? So I came in with 0. Now I have negative 50. Does that make sense? Someone else comes in with 50. Now they have 0, right? Someone else comes in with 100. Now they have 50. Does that make sense? The new average just gets reduced by 50. So if the old average was 50, the new average is 0. Does that make sense? Because we subtracted the average from them. Does that make sense? Does that make sense? That's what this is saying, though. Do you understand? Do you understand? This is saying if you took any random variable, it doesn't matter what it is, all right? And you start subtracting the average of that random variable from it, right? And started asking, what is the average of all of that? 0. Does that make sense? Always. Do you understand? All right, whatever. This here means we can take this and separate this also. Because these two things are independent from each other, it says when these things are independent from each other, then you can just do the I don't know why I wrote this backwards, but you can just do this X and then the Y. Does that make sense? So this is like X, this garbage. This should say Y right here. So in other words, I'm going to do now the expectation of the first part times the expectation of the second part. What is this equal to? Or this one? Sorry? This right here is the exact same thing as this. Is that correct? It's this. That's correct. I like that though. I like saying it that way better actually. So this is a variable minus the mean of that variable. Is that correct? This is some other variable minus the mean of that variable. Is that correct? What's the average of all that crap? 0. What's the average of all this crap? 0. Great. This is 0. Does that make sense? Only if these things end up being independent. Otherwise, they wouldn't sit here and name it and stuff like that. Does that make sense? But then this ends up being 0. Great. So we just showed this is true. Anyway, all this is explaining to you is that the variances just always get bigger. Does that make sense? Does that make sense? Question with this? All right, there was something else I was just about to prove. Oh, yeah. So we started talking about this Z garbage here, okay? There's going to be some very important results that we're going to have to say about this also, all right? Because it's like, why the hell did they start saying this? Where did that come from? Does that make sense? Right? Well, it turns out, based off what we just said just now, this is going to actually be really easy to explain where they just came up with this stuff. Does that make sense? Or why they're saying it, okay? It's easier if we can say that the mean of something is 0. Does that make sense? It sort of just makes more sense. It's like the positive stuff. The positives over here, I guess. The positive stuff and the negative stuff kind of just like balance each other out. Does that make sense? So you get 0. Does that make sense? Somehow that's like easier to calculate stuff. That's why they start calling things centered. Does that make sense? Right? You saw that here also. Stuff started becoming 0. Is that right? Like that's simpler. I don't have to calculate all this crap. It just 0. Does that make sense? Right? So like the this. So given some random variable x, all right, let's assume now the mean of x is mu. And the variance of x, let's say, is sigma squared. Does that make sense? Does that make sense? So who cares about z? Why are we doing this? Does that make sense? Well, first, what is the expectation of z? The expectation of z is the expectation of x minus the mean over the standard deviation, right? I'm just substituting. Does that make sense? Does that make sense? Z is equal to this. I'm just writing z there. Is that correct? But this thing is constant. This thing is constant. The x is the only random part. Does that make sense? So I can take this constant out. You would get 1 over sigma times e of x minus the mean. What is this equal to? What's the average of x minus the mean? That's when it's squared. Does that make sense? I don't blame you for saying that, but that's when it's squared. Does that make sense? Right? That's really the definition of standard deviation. This is this. Does that make sense? But I'm just asking, what is this? Simpler. Does that make sense? So we took the random variables and we subtracted the mean first, and then we started asking what the average of all that would be. The values, the average of the values minus the mean. Yep. So this is equal to this minus the mean of the mean. The mean of the mean is just the mean, like it's not random. So then this is also the mean. The mean minus the mean is 0. Is that correct? So this part's 0. So that means this is all 0. So the expectation of z is 0. It's centered. We subtracted the mean. Does that make sense? Does that make sense? All right, what is the variance of x minus the mean all over the standard deviation, right? By definition, variance is e of x minus mean over standard deviation squared. Is that correct? Oh, sorry. It's this thing minus the mean of this thing. But we just said the mean of this thing is 0. Is that correct? So now it's this. But then again, now this mu and this sigma thing are constant. Is that correct? Now I'm going to take this out. What is this now? What's the expectation of the value minus the mean all squared? Squared though. Variance. But that's your it's this thing. Does that make sense? Okay. that make sense? That's the definition of the variance. Is that correct? This is this. I assume this was equal to this. That means now this is 1. Does that make sense? So if x is a random variable, E of with a mean and standard deviation, E of this, which is just the same thing as E of z, is 0. And then variance of z is 1. Does that make sense? Those are like the simplest possible things they could be. Does that make sense? We can't make the variance equal to 0. That means it's not random. Is that right? The variance has to be something. So 1 is the nicest number it could be. That simplifies all the calculations. So that's why they're sitting there and trying to make, that's why they make this z thing. Does that make sense? But the mean every time when you do z, the mean of the z's has to be 0, right? That's what, oops. That's why when we were saying before, we were saying, oh, it was like -1, 1, and then we were saying 0 there. Is that correct? It has to be 0. Does that make sense? Does that make sense? Question with this so far? Good, I think it's over. No, wait, one more thing. We have to still show the binomial stuff. Turns out this will be easy now. Well, it's something, let's say that. All right, so I said I wanted to show where these things came from. Is that correct? Does everybody see that? No, I think I wore the wrong shirt today. That was the problem. So this. No, I swear this is actually helpful, believe it or not. All right. And what we're gonna do now, hopefully, is gonna make some sense. I'm gonna do it with numbers also, and then I'm gonna try and do them at the same time. Does that make sense what I'm saying? So I'm gonna try and do it with the variables and all that crap, writing out the formula and all that nonsense, but I'm also gonna try and do it with numbers, and then I'm gonna be like, yeah, I guess it's kind of it actually makes sense in this case now. All right. But the point is that this stuff is all in general. This stuff is hard. Does that make sense? Very hard, actually. Okay. So but this now hopefully gives you a little bit of intuition and makes you understand some of the things I'm about to do now a little bit better. Does that make sense? All right. But this is hard. Okay. You don't have to really do this, to be honest. This is just how it gets explained. Does that make sense? But every time when I was in this class and they would start explaining something new, and I would be like, I don't remember and I don't get it, or something like that. Once they taught me this part, I just kept writing it out this way, and then it all kept making sense. Does that make sense what I'm saying? All right. All right, let's see. So binomial probability distribution, whatever, right? We said that if xi, we said is binomial, and we said we need these things n and p to start describing it. Is that correct? We haven't talked about this at all today, so let's see how much you remember from last class. Plus, this is on your test also, right? So, what does N and P mean again? Probability of what, though? We keep doing this. You keep playing this game with me. It's very bad when you just say probability. Does that make sense what I'm saying? Because then, like, honestly, I don't even know if I know what it means then. What did binomial mean? Remember? What was the bi part? Go ahead, sorry. Probability of success is correct. Remember that? Binomial, we had the two choices each time. There was the N trials. Is that correct? There's two. You could either have success or failure, right? So you just call something success. Does that make sense? Then everything else has to be failure. Is that right? But then we say that the chances of success has to be the same on all the trials. Is that right? They have to be independent from each other. It can't keep changing. It's not like you're sitting there and you're taking a bag of marbles and you're drawing the marble out each time. Does that make sense? It's like the same bag of marbles each time. Does that make sense? What's the chance you get a blue one? What's the chance you get a blue one? What's the chance you get a blue one? Whatever. Does that make sense? Right? Blue, let's say, was favorable. Whatever. Does that make sense? All right. So N was the number of trials. Is that right? P was the probability of success on any of the one given trials. Is that correct? Does that make sense? All right, you remember what these things are? All right, let's make up more stuff now. So so then they start saying that they named another. It turns out there's another random variable that we can make up that somebody came up with first. That explains this very well. Okay, that helps to explain this. All right. So there was this dude's name. This used to confuse the shit out of me because of the way this guy's name is. All right. But this guy's name is Bernoulli. So they call it a Bernoulli random variable. All right. Turns out this dude just invented all this crap. So they name everything after him. All right. So so there's something called Bernoulli random variable. Sometimes people also call things Bernoulli trials. Okay. So every time we kept referring to a trial before, people call it Bernoulli trials. All right, because whatever, this guy came up with this shit. All right. What is a Bernoulli random variable? Well, it reminds me really of like a coin. All right. So we start saying like xi is a Bernoulli, and we have to say this p thing. Does that make sense? What does p mean again? Success specifically, though. All right. So then p again is just representing the probability of success. What was q again? Probability of failure. What's the relationship between these two things? They're complements, right? So p plus q has to be what? 1 or 100% is correct. In other words, q is just I'm in class. I don't think you can hear me. One second, sorry. So q is just going to be 1 minus p, right? That's the formula for complement. Is that correct? All right, but this is simple now. We just have two outcomes. Does that make sense? We're flipping the coin. We either get heads or we don't. Is that right? But this ain't your normal coin. This is like a magic coin. All right. Where all of a sudden we can start saying that we change how often we're going to get heads. Does that make sense? Once I say how often we're going to get heads, though, it stays forever. Does that make sense? All right. So how do we define this thing? So then if we want to define this thing, again, usually it's helpful to define random variables in terms of their probability distribution. Is that correct? Right, that table, xi, probability. Usually they write it like this. So they start writing the x's here and they write the probabilities there, but then they don't say this. Does that make sense? They just don't write it. All right. So what are the different possibilities? Well, we can either get heads or not. Is that correct? So then we're going to say one means when we flip the coin, we got one heads. Does that make sense? Or you had one baby and it was let's say you were looking for girls. One girl. Does that make sense? All right, whatever. Does that make sense? Something you're calling success. Does that make sense? All right, then we say that the probability of this particular event, we say is P, and the probability of this event is Q. And again, really, we're just thinking that this means these are the different possibilities, and these are the probabilities of those possibilities. that make sense? You understand? Okay. Yes. All right. So let's try and do it with a number also. Okay. So let's say I'm cheating. We're gonna play a game. We're gonna flip a coin. I'm a cheater. I don't tell you I'm cheating, obviously, though. Does that make sense? I was a bad cheater. No, but no, I don't tell you I'm cheating. Does that make sense? You start looking now. Anyway, so the no, but the but I don't tell you I'm gonna cheat. Okay, I don't tell you how I'm gonna cheat. But you start playing with me, and all of a sudden I keep winning. Like we keep flipping the coin, and I just keep winning. Right? I'm like, I'm gonna take heads each time. You take tails. All right. And then all of a sudden I keep flipping the coin, and we flip the coin like 10 times, and I win like 7 times. Does that make sense? And then we flip the coin like 100 times, and I win like 65 times or something. All right. And then we flip the coin like 1,000 times, and I win like 705 times. Okay. And you're like, wait a second. I'm supposed to win 50% of the time, right? And we were supposed to win. And then I'm like, bro, I'm not cheating. Come on. And I'm me? Come on. All right. Okay. And then I'm like, let's just play some more, right? Let's just gamble a little bit more. You're only gonna lose a little bit more, but don't worry about it, right? Let's just play some more. Okay. So we play more, we play more, we play more, we play more, we play more. Let's say we play like 1,000,000 times. Does that make sense? But now we start getting somewhere around like 700,000 times I won. Does that make sense? Now you're like, wait a second. This shouldn't happen. Does that make sense? If the average should be that each of us have, or excuse me, the chances that both of us are going to win is equal, right? Then if we keep playing more and more and more and more times, it should start becoming even. Is that correct? Does that make sense? But it's not. It's staying not even. Does that make sense? Do you understand? So what I'm trying to describe here is if we had this coin where the coin was giving us, let's say, 1 70% of the time and 0 30% of the time. Does that make sense? Right? Okay. Now we were talking about before, really all I'm trying to say here is what's the mean and the standard deviation of that binomial random variable, right? First, let's talk about the mean and standard deviation of this thing, because this is really just one of the trials. Is that correct? Does that make sense? And then each of the trials are independent from each other. Is that right? So maybe we can use some of the stuff from before. Does that make sense? All right. So what is the mean and variance of a Bernoulli random variable? All right, let's see if you can help me with this. And I want to do it with both of these here. So we can do it with numbers and we can do it without them. Does that make sense? All right, let's see if we can remember how to do this. How are we going to calculate the mean of this thing? Yeah, but I'm giving you in terms of the probability distribution. Is that correct? Now, we talked about this a few times and we said there was a bunch of ways that we can actually talk about. Oh, good girl. Good girl. I like that. I like that. What'd you say? Whatever, single lady. All the single lady. All the single lady. Boy, I'm gonna miss that next semester. All right. 0.7 is correct for this, but how do we remember it with the formula? Let's do it with all the formulas and all this bullshit also. Okay, you can do it on the calculator for sure. You type these in one, type these in the other one, just do one of our stats. Yes, 0.7 is right. Does that make sense? All right. But it turns out even doing this with the formulas is going to be easy. Okay, because there's not that many events. Does that make sense? All right. Let's just recall what the formula is for any random variable. The formula for any random variable for the mean is equal to, it's the sum of the values times their respective probabilities, and we just add them all up over the entire sample space. Is that correct? So in other words, if I do this or this, that's the way I have to do it. I have to do the sum of the values times the probabilities of those values. The sum of the values times the probabilities of those values, right? All right, what's it gonna be? How do I write it out for this here? What would I write? The value, this one's like we would say like I here is 1 and this is 2. Does that make sense? Does that make sense? So it's x1 times p1, right? x2 times p2. Is that correct? Does that make sense? Shamal? 1 times 0.7 plus, I'm just going to write it out the first time, x1 times p of x1 plus x2 times p of x2. Then this is going to be 1 times 0.7 plus 0 times 0.3. Is that right? Which is 0.7. Does that make sense? Does that make sense? Yeah. 70% of the times you get a heads, right? So it's saying if it's calling a head 1 and this 0, it's saying the average of what you should get should be around 0.7. It can't be 0.5 anymore. Is that correct? Has to be higher. Is that right? Does that make sense? All right, what about this here? All right, well, there's a little trick that people like to do. I mean, trick. Instead of writing Q, if we write 1 minus P, everything is in terms of P. Does that make sense? Say it one more time. No, it was 0.7. Because we were getting... No, just mean. But the thing is if we say you can only have 0 and 1 as your values, there's no way we're going to get 1.5 as the average. We're not even getting that for any of the values. Does this make sense though, guys? Do you understand? All right, this here now. How would I do this for this now? What do I write? Somebody help me. All right, come on. Sorry? No. Yep. This one times this one. Whatever this is. 0 times 1 minus P. Is that correct? Or Q. Doesn't matter. That part's 0. We get P always. Does that make sense? Does that make sense? Right? If the coin was 80% of the times it would be heads, then the average would be 0.8. Does that make sense? If the coin was 20% of the time heads, the average now would be 0.2. Does that make sense? You get what I mean by this? You understand? All right. All right, we still need to do the variance though. Variance is always a little bit more annoying. So now I need to calculate the variance of xi, and we'll try and do it with the numbers here also, just to see if that helps. I don't know if it's going to help as much as the previous one. It sort of made sense. You understand what I'm saying? So the formula is a little funny. All right. All right. First of all, we need to remember what the definition of variance is. Definition of variance is the expectation of the x value minus the mean of that value squared. Is that correct? Well, we already got the mean. What's the mean? That's correct. Or just P. Does that make sense? But you're correct. Does that make sense? So in other words, if we're going to do this one down here, it really means I got to write this. Because the mean is 0.7. Is that correct? Does that make sense, guys? All right. What does this stupid thing mean? This one says E of xi means you write xi and then P of xi here. This then says you need to write sum of x Why, what's up with the disappearing ink? Xi minus the mean squared times the probability of Xi. Whatever you write here goes there, then there's a probability. Whatever you write here goes there, then there's a probability. Does that make sense? All right, somebody help me write out the bottom one first, please. See if I can get this back over here. Yeah. How do I write this out now? The sum of xi minus 0.7 squared times the probability of xi for this thing. What would it be? What do I write? And just remember we have to do this, whatever this is, for all the events in the sample space. Does that make sense? But there's only two. So do it. Well, I don't want to write sum anymore. I want to write out what it actually is. So what's the first number and what's the second number? How do I write it out? Very good. 1 minus 0.7, but then it says squared. Does that make sense? Times what? There's still something here. Times 0.7. Does that make sense? Plus, then what do I write for the next one? Nope. 0 is correct. Now we have to go to the next event. Does that make sense? Not 0 minus 0.3. 0 minus 0.7, the mean is still 0.7. Does that make sense? Then the probability of this getting 0 is 0.3. So we have to weight that often. Does that make sense? Does that make sense? This occurs less often than this does. Is that right? Does it make sense, guys? Chloe, question? All right, so then what is this garbage? 1 minus 0.7, I'm not going to write it out and calculate everything because I want it to match up with the formula on the other part. All right, but 1 minus 0.7 is the same thing as, that's really like Q. That's this. Does that make sense? So I'm going to leave this as 0.3 squared. I'm not going to multiply it. 0.7. This is the same thing as 0.7 squared. Now, both of these each have a 0.3 and a 0.7 in them. Does that make sense? I'm going to factor these out. And then the first part, there would be a 0.3 left over. The second part, there would be a 0.7 left over. Does that make sense what I just did? Divide this by 0.3 and 0.7, you would still have 1.3. Divide this by 0.7 and 0.3, you would still have 1.7. Does that make sense? What's 0.3 plus 0.7? 1. And it turns out this is the answer, like P times Q, always. Okay? So I can do that here also, supposedly. So then this is going to be, I'm going to do it now with this chart now. Okay? So the average was P. So this is 1 minus P squared times the probability that the 1 happens, which is P, plus 0 minus P squared times the probability this happens, which is 1 minus P. Now I got to do some stupid algebra, okay? But believe it or not, it's the exact same crap I was doing down here, all right? So now there's like this is the same thing as saying P squared. 0 minus P squared is the same thing as just P squared. So now look what we have. 1 minus p squared, 0.3 squared, times p, 0.7. P squared times 0.7 squared. 1 minus p, 0.3. Does that make sense? So I can remove from this a p and a 1 minus p. Then what's left over? In the first part, there would still be a 1 minus p. In the second part, there would be a p. Then you have 1 minus p plus p. These two things cancel. You just get 1. So therefore, we get p times 1 minus p. All right, so that's the variance, and that's the mean of one trial. Does that make sense? Does that make sense? If this is the variance of one trial, then the standard deviation of one trial is just the square root of the variance. So then we get square root of p times 1 minus p. Does that make sense? All right. Now, we're almost done. All right. So now we know the mean and the variance of one trial. Is that correct? Oh, I shouldn't have written this over here. That was so stupid. That work? Anything working? Or I just shut this off. All right. So a Bernoulli random variable is very closely related to a binomial random variable. A binomial random variable is just the number of successes on n trials. Is that correct? So if you did this n times and then just add it up, whether you got a success or not, we would call that a binomial. Does that make sense? Did you get a success on the first one? Oh, you did. Okay, 1. Did you get a success in the second one? Oh, you didn't. Okay, 0. Did you get a success in the third one? Oh, you did. Okay, 1. Oh, so now you have 2. Does that make sense? No. Bernoulli is one trial. Binomial means a bunch of trials. Does that make sense? But very closely related. Like each time 2 outcomes, but on each trial. But now all of a sudden we're saying there's 12 trials. Right. All right. So then this is now, so if we say yi is binomial, then yi we say is binomial with parameters we need to know what n and p are before. Is that correct? Right. But we can just say yi is really just equal to the sum of n Bernoulli random variables. Does that make sense? As long as x is Bernoulli with parameter p, that's each individual trial. Does that make sense? Chloe? Now here, Now I'm just going to use all the stupid formulas. I'm going to get the answer very quickly now. Does that make sense? It's going to take like 2 lines, honestly. All right. So now I want to know what the mean of the binomial random variable is. The mean of the binomial random variable is the same thing as the mean of the sum of these x things. So this would then mean this is equal to the first trial plus the second trial plus the third trial until we get to the nth trial. Does that make sense? Does that make sense? But then expectation is a linear operator, or we can start separating these things with the plus. We can just keep adding them all individually, right? The mean of all of this crap added up is the mean of the first one, plus the mean of the second one, plus the mean of the third one, plus the mean of the fourth one. Does that make sense? So then this is going to equal to the mean of the first one, plus the mean of the second one, plus the mean of the last one. Does that make sense? All right, now, this one part can become confusing sometimes, but it's really stupid. All right? What's the mean of the first one? And remember, x means it's Bernoulli. Is that correct? The mean of that. X1 is the outcome on the first trial. What are the possible outcomes it could possibly be? 1 or 0. Is that correct? 1 happens with probability P, 0 happens with probability 1 minus P. Is that right? What is the mean of this? It's the mean of this. Does that make sense? What did we say the mean of this was? When we were doing the numbers, yes. In general, just P. Does that make sense? So that means this one's P. Is that correct? What about the second one, though? What's that going to be? The average. That's correct. From the same damn coin. Does that make sense? If it's 0.7 for the first one, it's 0.7 for the second one. Is that right? What's the rest of these? P. Does that make sense? What would this equal to then? Sorry? N times P. And that's what we said a long time ago. Is that correct? Does that make sense? You understand? If there's 1,000 babies and you say 70% of the time it's going to be a male, then we would expect there to be 1,000 times 0.7 for 700 males on average. Does that make sense? Does that make sense? Questions so far? All right. Now we got to do variance. Is that right? So now what is the variance? Oh, by the way, hopefully you also see why anybody ever talks about variance. I had to keep doing it here over and over and over again. Start calculating all this stuff. Does that make sense? It turns out it's simpler to calculate variance because it doesn't have the stupid square root. Does that make sense? Does that make sense? So we always figure out the variance first, and then you're just like, oh, what's what's standard deviation? Take the square root. Does that make sense? All right. So that's why I'm finding out variance. I want to actually just find out standard deviation, but it's too hard. Does that make sense? All right. So variance of this random variable, yi. All right. Well, yi is this Bernoulli thing or whatever. So that's the variance of the sum of whatever the individual trials were. Is that correct? This then is the same thing as the variance of then this would be, I guess, like x1 plus x2 plus whatever, however many trials there were. Does that make sense? Does that make sense? But now we use all the cheating stuff. I don't want to write out all this crap. Okay? That's why I did the stuff from before. Does that make sense? Does that make sense? We came up with some stuff with variance before, okay? I said, like, if these things were independent from each other, then all I have to do is really just start adding the variances. Is that correct? Does that make sense? Do you remember that from before? We said that if you had, whether you add or subtract these things, right? This ended up getting more spread out. Is that correct? Does that make sense? I could prove this too with numbers. Like, do this is another one we can do. It's called uniform distribution. All right, which we'll do in the next chapter. All right. I know you're really excited. So then the this right here, variance of x plus or minus y, right? Is just the variance of x plus the variance of y. Does that make sense? Well, look what we have here. Hopefully. This is adding a bunch of stuff. But we said the trials have to be independent from each other. Is that correct? That means these things are independent from each other by definition of binomial. Does that make sense? So that means this then has to be the variance of the first one plus the variance of the second one plus the variance of the last one. Is that correct? Okay. What is the variance of the first one? Well, we said right here it was t times 1 minus p. Is that correct? Does that make sense? But that's what the next one would be also, because it's the same. And then there's more of these. And then there's n of them. And then 1 minus p is the same thing as q. So we get npq. Does that make sense? Does that make sense? But then the standard deviation is equal to the square root of the variance, which is then the square root of n times p times q. And then this is the formula that you need to be able to know. Does that make sense? So you need to know this result, and this result, but you don't really, honestly, you don't really need to be able to do any of this. Does that make sense? Does that make sense? I do think it's way more helpful, and I do think it's way more important than honestly the rest of this stuff. And I do believe that if you do these things, there are only a couple more classes that you would have to take before you can make like a bunch of money. All right. I wouldn't bother with this bullshit if I didn't think you can make dinero. All right. But so I told you I was like good at calculus and stuff like that. I did all this math competition bullshit when I was a kid. And then someone turns around to me and is like, yo, you're good at this stuff. You should take the actuary tests. And I was like, actual what? Well, actuaries are people that study distributions and deal with things associated with populations and stuff like that. So like a lot of what's really, really, really important for the government is understanding things about demographics. How many women, how many men, how many this, how many that, how many boys, how many girls, how many whatever, right? How much, how much power do people use in this area? How much, like all these things. Does that make sense what I'm saying? But not just that, like companies need it too, right? Because they have to determine how much money they want to spend in this area so that they can make the right amount of right decisions and etc. Right? So then so analyzing populations and understanding large groups of data and stuff like that, like these, they're all related to each other. Does that make sense? It's just easier for me to understand if I talk about people than if I start talking about, some other crazy thing. Does that make sense what I'm saying? So someone's like, oh, you can do this actuary stuff. And I was like, what is that? I don't know what that is, right? And then they're like, you got to take these tests. They're really, really, really hard. And they're pretty hard. Okay. But any test that you have to take to get a job, there's one good thing about it. They don't usually change very much. Does that make sense? It's hard. It wouldn't be hard. I mean, there'd be no reason for you to do it if it wasn't hard. They wouldn't pay you otherwise. Does that make sense? So it's hard, but if you actually wanted to do it, you just keep studying, right? Like nursing, for instance, a lot of students want to do nursing at this school and stuff like that. It's a pretty good program. You make a lot of money, honestly, doing it. But there's this HESI exam and there's this other stuff you got to pass it. Okay. And I see people sit there and take it a couple times and stuff like that, but that's actually not so good. Like you should really be able to pass it the first time if you're trying. Does that make sense? Otherwise, you'd maybe didn't take the right classes beforehand. Does that make sense? So then all I'm trying to say though is there's a way to prepare for that. It takes time, a bit of time. Once you spend the time doing it, you're going to be able to do it. Does that make sense? All right. So it's just like this is just another one. You get what I mean? But the difference is that when you talk about nursing, there's a lot of people that think they can do it. Does that make sense? When you talk about this bullshit, there's a lot of people that sit there and be like, fuck that. Okay? Which is good. Because then if my ass has to study for it, I'm not going to have to study as hard. Does that make sense? So the first actuary test, I paid $325 for the test. I paid, I think it was like $175 for one book and $175 for another book. Never opened the books. Okay? Forgot that there was the test even. The day before the exam, I remembered. I was like, you should study. I went and got the book, started reading it. I was like, the book's not good. I learned this in school, it was better. I was like, I used to do math competition. There's got to be some practice tests. I'll just do the practice test. Right? That's what I learned from math competition. Just do all the practice tests. You'll be fine. Okay. So so I was like, all right. So they had a practice test posted online. One. Couldn't find any more. Turned out one of the books I bought was a bunch of practice tests though. Started doing the practice test. I was like, how long is this freaking test? 3 hours? Started doing the practice test. I was like, shit, I don't remember all this stuff. When I started looking at the problems, I was like, it's not that bad. I did like 2/3 of the practice test. Took me like 2 or 3 hours. All right? I think 3 hours. Went to bed. Woke up in the morning. Did the last couple questions. Don't know why I had a problem the night before. It was actually easy. All right? Went and took the test and passed. That's how long it took. Once I did the regular stuff in school properly. Does that make sense? All right. But the calculus and that stuff is, it's hard. It's annoying. All right. But the thing is all I'm trying to say is that if it's something you wanted to do, there's absolutely no reason why you couldn't. All right. And the difference is that a lot of people try this one, not so many people try that one. Usually better to avoid the crowds. When it comes to a job. Does that make sense? All right. Because you don't want these people to all be competing with you. And that's the surprising thing about this country, that there's many, 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 many jobs out there that are really, 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 really good. But very few people are qualified for them. So they keep paying these people more and more and more and more money for some of this stuff. But other people keep turning around and saying that they don't want to do the schooling or pass the test or something. Does that make sense? All right, that is all.